viewers, welcome back to our YouTube channel. So in our previous class we talked about the rules of indices. The rules of indices. But in today's class we're going to apply all those rules that we discussed earlier. We're going to apply them in solving a problem in mathematics. But before we proceed, let's quickly recall that indices is a way of expressing a word, a very large number in a simpler manner. In other words, indices is simply used to reduce a very large number, a very large product of number to the simplest form. And the plural of index is known as indices. Now, the first law of indices, which is known as the product law, is stated here that when you're having the same base, when an index is having the same base, that index is going to be what? Added together. Now, the second law is the division law, which is also known as the quotient law. Now, the quotient law shows that when the bases are the same, are meant to be subtracted. The third law is the power law. The power law says that when a base with an index m is what is being raised to another index n, the two index are meant to be multiplied together. Now, the fourth law is called the zero law. Now, the zero law says that when a base is having an index of 0, then the answer is going to be 1. In other words, any number raised to the power of 0 is always equal to 1. That is, when we apply our quotient law here, a base having the same index, the rules of indices say that when a base of the same index is then divided, the index are going to be subtracted. And when the index is subtracted, we're going to be having a 0. And the base raised to the power of 0 is going to be equal to 1. Now, the fifth law is the product power law. And the product power law says that when two bases, A and B, are being raised to an index of x, the index of x is going to be distributed all through the bases in the bracket. That is, we have A raised to the power of x times B raised to the power of x. Now, you cannot apply the multiplication law here because the bases are different. They are not the same. So, in this case, you cannot simplify further. So, as we proceed, we are going to encounter a question of this kind. Now, the sixth law is called the negative index law. And what does the negative index law say? The negative index law says that when a base is raised to a negative index, the base is going to be expressed as the reciprocal of the positive index, as we have it here. When you have A raised to the power of -1, this can be expressed as 1 over A raised to the power of n, which is the positive, not negative element. Now, the seventh law is the root power law. The root power law. Now, the root power law says that when we are having a base raised to to a fractional number of this kind, that is, we are having a base raised to the power of 1 over n. The base raised to the power of 1 over n. In this case, we're going to be having an n root of the base A given to us. Now, the n root could be any number. It could be 2, it could be 3, that is the square root, cube root, fourth root, as the case may be, and raised to the power of 1. The 1 is not significant. You can easily raise the 1, so it doesn't have any significant value to the number. So you can raise the 1, you can raise the 1, as the case may be. Now, the eighth law of indices. The eighth law of indices is similar to that of root power law. The difference between the root power law and the fractional index law is that the fractional index law is having a fraction of different values and not 1 over n or 1 over 2. The n could represent any number. But in this case, the n stands for a particular number and the n also stands for a particular number. For instance, we can have 3 over 2. Now, when we're having a base with an index of, let's say, 3 over 2, this can be expressed as the base, the square root of the base raised to the power of n. Don't forget, I told you that you can easily have 1 here, but the 1 does not have any significant value. But in the case of fractional index law, we have to indicate the index of the value given to us. The m could represent any value. Now, let's apply this law in solving this exercise one after the other. Now, let's go. The first question says that we should evaluate 2 raised to the power of 1 over 2 times 2 raised to the power of 1 over 2. Now, in this case, the law we're going to apply here is what? Is the multiplication law, the product law. Now, for the product law, since the bases are the same, we're going to have what? 2 raised to the power of 1 over 2 plus 1 over 2. We're going to add up to what? The index, since their bases are the same. Now, adding up this index, we're going to apply our what? Our knowledge of fraction. Fraction with the same denominator. So since the denominator are the same, so we're going to have our what else into 2. So 2 in 2 is 1, 1 times 1 was 1, 2 in 2 again, 1, 1 times 1 is 1. So we're going to be having 2 raised to the power of 2 over 2. And 2 over 2 can be expressed as what? As 2 raised to the power of 1, which is still the same thing as what? 2. Now, to solve question 2, the law we're going to apply here is what? The Rhodes power law. The Rhodes power law. Now, since we are given a value of n raised to the power of 1 over 2, to solve this, you apply your what? The root power law. And what does the root power law say? The root power law says that when you're having the value of this kind, we're going to be having what? The square root. The square root of n raised to the power of 1. Now, what is the square root of n? 3 times 3. That's going to give us what? 9. So, 3 is the square root of what? Of 9 raised to the power of 1, which is still the same thing as 3. So 3 is going to be our final answer here. Now, question 3 says that evaluate x raised to the power of 4 over 3. Now, to solve this problem, we're going to apply the fractional index law. Now, we're going to be having cube root of 8, close the bracket, raised to the power of 4. Now, what is going to be the cube root of 8 is going to be 2. 2 times 2, 3 places. That will be what? 2 raised to the power of 4. 2 raised to the power of 4 is an index expression of this particular question given to us. Now, if the examiner wants you to express this in an expanded form, then you're going to be having your value as 2 times 2 times 2 times 2. And 2 times 2 is 4, 4 times 2 is 8, 8 times 2, that's going to give us what? 16. So your final answer here is going to be what? Going to be 16. Now, fourth question says, evaluate 2a raised to the power of 3, close the bracket, raised to the power of 2 times 4a raised to the power of 6, close the bracket, raised to the power of minus 2. Now, to solve this question here, we're going to apply our product power law. The product power law, and what does the law say? The law says that when you are having an expression 2a raised to the power of 3 and close the bracket, raised to the power of 2, you're going to distribute the index outside the brackets. You're going to distribute it all through the value or the variables numbers given in the bracket. Now let's distribute the index given here. So we're going to be having 2 raised to the power of 2 times a raised to the power of 3 times 2. Now for this 3 times 2, we'll just apply our power law. That's the power law. This one is the product power law. We have distributed the index outside by the number given in the bracket, and here we just apply our power law. Now times 4 raised to the power of minus 2 times a raised to the power of 6 times minus 2. 6 times minus 2. Now let's solve completely. This will give us what? 4. This will give us 4 times a raised to the power of 6 times 1 over 4 raised to the power of 2. Don't forget the negative index law that we discussed earlier. The negative index law can be expressed as the reciprocal of base with a positive index. So that's just what we just done here. So we're going to be having times a raised to the power of 2 times minus 2 is going to give us what? Minus 12. Minus 12. So we can solve for that by saying 4a raised to the power of 6 times 1 over 4 raised to the power of 2 times, now we need to express this a raised to the power of minus 2 as a reciprocal of the base with the positive index. So we have 1 over a raised to the power of 12. So now we can say 4a raised to the power of 6 divided by 4 raised to the power of 2 a raised to the power of 12. Now I can re-express this as 4a raised to the power of 6 divided by 4 raised to the power of 2 a raised to the power of what of 12. Now to solve this further, we're going to apply our division law. And division law now, don't forget this 4 is having an index of 1. So here now we're going to be having 4 raised to the power of 1 divided by 4 raised to the power of 2, and we have times a raised to the power of 6 divided by a raised to the power of 12. Now, since the bases are the same, we're going to be having 4 raised to the power of 1 minus 2 times the bases are the same here too, a raised to the power of 6 minus 12. 6 minus 12. So I can re-express this as 4 minus 1 times a minus 6. So I'm going to express this as the reciprocal of the negative index, which is going to be 1 over 4 times 1 over a raised to the power of 6. So my final answer is going to be 1 over 4 a raised to the power of 6. So this is going to be our final answer. So the fifth question says evaluate 16 raised to the power of 3 over 4 times 4 raised to the power of 1 over 2 divided by 8 raised to the power of 5 over 3 divided by cube root of 8 raised to the power of 5. Now the fourth root of 16 is 2. That is 2 times 2 times 2 times 2, 2 times 2, 4, 4 times 2, 8, and 8 times 2 is 16. So the fourth root of 16 here is 2 raised to the power of 3 times square root of 4 is 2 raised to the power of 1 divided by the cube root of 8 is going to be 2 as well. 2 times 2, 4, 4 times 2, 8. So we have 2 raised to the power of what of 5. Now, in this case now, we can re-express this. Let's solve this first one, which is the multiplication law. Applying multiplication law, we're going to be having 2 raised to the power of 3 plus 1. Since the bases are the same, over 2 raised to the power of 5. So 2 raised to the power of 3 plus 1 is going to be 4 divided by 2 raised to the power of 5. Now, applying my division law, which is the quotient law, I'm going to be having 2 raised to the power of 4 minus 5. So my answer is going to be 2 raised to the power of minus 1. Now, for the 2 raised to the power of minus 1, that is the negative index law. So negative index law can be expressed as the reciprocal of 2 raised to the power of 1. Or you can express it as 1 over 2. That's our final answer for the fifth question. Now, the sixth question says evaluate open bracket 16 over 25 close bracket raised to the power of 1.5. Now, when you encounter a question of this kind, all you need to do is to consider the decimal point by changing it to a fraction for easy evaluation. So to solve this now, we're going to be having 16 over 25 to close the bracket. So 1.5 in fractions is going to be 15 over 10. That is, if you divide your 15 by what? By 10, you're going to be having what? 1.5. Now, this 15 over 10 can also be simplified further. So we can have 16 over 25 raised to the power of 3 over 2. 5 in 10 is 2. 5 in 15 is 3. So, having this expression now, we're going to come back to the fractional index law. Fractional index law, this is going to apply to all the number in the bracket. We're going to apply this fractional index law. It's going to be applicable to all the number in the bracket. So we're going to be having the square root of 16 over square root of 25, everything raised to the power of 3, the numerator. Now square root of 16, that's going to give us what? 4 over square root of 25 is 5, all raised to the power of 3. We are still going to distribute this 3 here. So we have 4 raised to the power of 3 over 5 raised to the power of 3. So expressing this in the expansion form is going to be 4 times 4 times 4 over 5 times 5 times 5. So 4 times 4 is 16, and 16 times 4 is going to give us 64. 64 over 5 times 5 is 25, and 25 times 5 is going to give us 125. So this is going to be our final answer for this sixth question. Now let's move to the seventh question. Seventh question says, evaluate 16 raised to the power of 0. Now to solve this question, we're going to apply the zero law of indices. The zero law of indices, and the zero law says that anything raised to the power of 0 will always give you what? 1. So 1 is going to be your answer. If you love this video, kindly subscribe to our YouTube channel and follow us as we draw the next question on application of the law of indices. So we're still going to continue with evaluation of the law of indices. We'll see you in the next one.
Hello everyone, welcome to